So we are going to derive the equations of motion using calculus. So consider a body whose initial velocity is u, initial velocity u. So the acceleration of this body is a, that is a constant acceleration a. So after some time, the velocity of the body will change from u to v. Okay, so after some time, the velocity changes from u to v. Okay, the total time taken for this to happen is t. Okay, during this time interval t, the displacement of this body is s. So initial velocity u, the constant acceleration is a, final velocity v, the time interval t, and s is the displacement. So we are going to derive the equations of motion. What's the first one? V equals u plus at. Second one is s equals ut plus half at square. Third one is v square minus u square will be equal to 2s. Okay, so we'll derive the first one. Okay, so what is acceleration? We know that acceleration equal dv by dt. Okay, so just cross multiply. A dt will be equal to dv. So integrate both sides. Integral a dt equal to integral dv. What are the limits? What are the limits of time dt? Is 0 to t. What are the limits of velocity? Initial velocity u, final velocity v. Okay, this integral a dt, acceleration is a constant. So we'll take out what is integral dt. Integral dt is t. Limits are 0, t. What is integral dv? V. Lower limit u, upper limit v. So just apply the limits. What is that? Upper limit minus lower limit will be equal to upper limit v minus u. So we got as at equals v minus u. That is v equals u plus at. Okay, so we'll derive the first equation of motion. Now come to the second case. What is velocity? Velocity is ds by dt, rate of change of displacement. Okay, so I can say that v dt will be equal to ds. So we'll integrate both sides. Integral v dt will be equal to integral ds. What are the limits? Time is 0 to t. What are the limit of displacement? 0 to s. Okay, in place of v, I'm replacing by u plus at into dt equals integral 0 to s ds. Okay, so I can split it into two parts. What is that? 0 to t u dt plus integral 0 to t at dt. What is integral ds? S. Apply the limits 0 to s. Okay, integral u dt, u is constant, taken out. So u into dt is, integral dt is t, limits are 0 to t. Here a is constant, take out. Integral t dt is what? T square by 2. Apply the limits 0 to t. Here we are applying upper limit minus lower limit will be s minus 0 s. So here also we'll apply the limits t minus 0 plus a into t square by 2 minus 0 will be equal to s. Okay, so what you will get? You got as ut will be equal ut plus at square by 2 will be equal to s. Okay, that is what s equals ut plus half at square. So you derive the second equation of motion also. Okay, s equals ut plus half at square. Now come to the third one. What is acceleration? Again, acceleration is equal to dv by dt. So I am multiplying numerator and denominator by ds. That is ds in numerator and ds in denominator. So what is this ds by dt? Ds by dt is velocity. So I can write acceleration equal to ds by dt is velocity into dv by ds. Just cross multiply. So a ds will be equal to what? V dv. Integrate both sides. Integral. What are the limits of s? 0 to s. Limits of velocity Initial velocity u, final velocity v. A is a constant, so taken out. Integral ds will be s. Limits are 0 to s. Integral v dv is v square by 2. Limits are initial velocity u, v. Apply the limits. A into upper limit minus lower limit equal to upper limit v square by u minus u square by 2. Sorry, it is 2. Okay, so as will be equal to v square minus u square by 2. That is v square minus u square will be equal to 2as. Okay, so we derived all the three equations of motion.